After the session, doubt clearances are not there. Of course, I will give you time, but that time you don't get anything in mind. If you have anything in mind, you can ask me also, no problem. But while and so you don't understand particular statement or a particular explanation, you don't get it. Okay, for example, you don't get it. You can ask me, I will explain it again. Even you have some separate doubt, new kind of questioning is there. Also, I will explain it, no problem. Okay. So for me, you are important. Your learning is important. For you also, it is your learning is important. And make sure everybody must go through once, at least once every day. What we are discussed that day, please go through once. Okay, give at least half an hour for what we have discussed. Technical. Minimum half an hour is important. Remaining stuff you can put it on your communication skills, exercises, PPTs. Okay, you can do that one. Yeah, anyway, we start networking basics. Actually, I put a basics to make sure that is like an interview also. When you say basics, they will go with this stuff, normal stuff on. Because it's a networking and what are we are covering here is not just the basics, guys, it is essentials. Okay, networking essentials. That's what we are covering here. Just I put a name basics instead of essentials. So networking essentials part. Mhm. The first thing is we need a network. Why we need a network? Why we need a requirement of network? Okay. Yeah. So there are several statements also. There's different people, different statements. We'll see those. To share information, data, other resources between the devices, we need a network. Okay. Some people say like to communicate between the devices, we need a network. So what it is? To communication purpose, we are connecting devices in the network. What is the purpose? For communication purpose. Then what is meant by communication? Then what is meant by communication? Communication means you are sharing of information, data, resources. That's what is communication means. I'm sharing my screen. I'm sharing my file, document, videos. So I'm communicating. Okay. Using Microsoft Teams, I'm communicating to you. I'm sharing my screen, my voice. Okay. So I'm communicating. You're communicating to me through this Microsoft Teams. Without network or internet, it's not possible. Okay. So to communicate, what is meant by communicating? To sharing of information, data, resources. Third statement. Yeah, I said communication, sharing information, data, resources. How you do it? So what is the types of communication? So communication is okay, but what are the different types of communication? How you share information, data, or resources? So meaning is different ways, different types of communication is there. Example, simple example, mail communication. You share your resume, photo, or maybe your documents through mail, right? So mail communication, WhatsApp-based communication, instant messaging communications. Okay. You upload a file, download a file, another communication. You're accessing a website, web-based communication. I have information, I put it in my web server. Through website, I put it in you can access through a website that information means you're accessing through website. Web-based communication. Web is another communication. Mail communication, file upload, download communication. Um, yeah, you're in a network, so authentication communication. You log in, log out through network. It is a authentication communications. Okay. Yeah. So different types. So many other things are there. for time synchronization, update, your system getting updated, right? Your operating system get updated, right? Update, that is another kind of communication only. Update files are downloaded, installed, and updated in your system. So update with some, there is a update server. You're getting updates from the server. Update related communication. Remote installations, operating system installation, application installations. Remote access related communication. You have a remote server, you're accessing from your desktop. Remote accessing. For example, if anyone go through this AWS or Azure cloud, say in a cloud it is virtual machine is running, a Linux-based virtual machine, you are connecting through your SSH using PuTTY through PuTTY, it's using SSH protocol, you are connecting and accessing remote server. Okay. So that is also kind of communication. So different types of communications are there. Mostly commonly we are using website, email, file upload downloads, instant messaging like a WhatsApp messaging. Okay. So earlier days Google Talk is there, Yahoo Chat is there, okay, MSN instant messaging, I am chat is also there. So instant messaging kind of communication. Different ways of communication is there. Okay. So I told three statement, right? One is why we need a network to share information or a data or resources between the devices. We need a network. The device has to be connected to the network so we can able to share information, data, and resources. Or also we can able to tell to communicate between the devices. We need an. Then I said, what is meant by communication? Sharing of information, data, resources. Alright? Communication. Different types of communication, mail communication, file upload, download, web related communication, remote access related communication. So many communication type things are there. Okay. Got this? So the network is a word which we use the network word in different places, different ways. So which place we are using a network word based on that meaning is also little different. Okay. Physical network, logical network, internal network, external network. Okay. Same network, different network, LAN network, WAN network. So different places we use a word called network. Here it is. Actually, what is a network? Why we need a network? And what is a network? Interconnection of two or more devices. So in the network, at least two devices required. Two or more devices required. With one single device, what you will do? So, so you connect the interconnection of two or more devices. We call it as a network. Simple network it is. So it is a network. So like this, we have a several networks, for example. For example, we have a several networks. Okay. So what is networking? Network means interconnection of two devices. What is meant by networking? Communication between the interconnected devices. For example, A is communicating to B. Communicating means it's a networking. Connected network. Communicating, networking. Okay. Interconnection of two or more devices, network. Communication between interconnected devices is networking. And if you have multiple networks like this, network 1, network 2, network 3, so there is a different devices in the network. These are different networks. They are communicating in their networks. For example, A2 is communicating to B2 or C2. A3 is communicating to B3 and C3. They'll communicate inside. But you want to connect these networks. If you want to connect these networks, so that is called a internetwork. That is internetwork connection of different networks. Of different networks, we call it as internetwork. Communication between different networks. For example, A1 is communicating to A2. So A1 is in one network, A2 is in another network. The communication between different networks, we call it as internetworking. Internetworking. So network is interconnection of two or more devices called network. Communication between two or more internet connected devices is called networking. Internetwork is a connection of two or more networks. Internetworking means communication between different networks. Okay. To make a network simple to understand, to make a single network, you need a device called hub or a switch. Hub is a device. Using this hub device, you can connect devices together so they can able to connected and communicate. Or also you can use a device called switch. This hub or a switch devices are used to make a simple and single network. Now you are having multiple networks. How to connect these multiple networks, like internetwork, and make them communicating each other means internetworking. We need a device called a router. A router is internetworking device which make a communication between different networks. Different networks. Guys, understand up to here? Any doubt, question? Very good. Yeah. Again, I said no, network means so how many places use this network word. So it depends upon where you are using. Okay, again, you have to check it once. Simple. Guys, this is certain devices are connected here, right? So devices connected. So what we call it as a physical network. There is 100 devices are connected in a network. Means it's a physical network. Maybe a 10 devices connected in a network is a physical network. Means devices are connected. It's a physical network. The next one is to communicate between the devices. These devices need an address. A logical address is required. The devices are connected. It's a physical network, but to communicate between the devices also need a logical address. Based on this logical address, you'll create a logical network. So in network again, physical network, logical network. Physical means you have a devices, you connected, it's a physical network. You can divide this physical network as a single or a multiple networks using logical address. using logical address. So that is a logical. Within a physical network, you can make entire network as a single network or multiple logical networks also. You can make entire physical network as a single logical network or multiple logical network using logical address. What logical address we are using is IP address. What logical address we are using? IP address. Okay. So based on using of IP address, we create a logical network. Physical network, logical network. So we'll first see about physical network. Logical network we'll see at the time of IP address. Okay. The physical network. It's a connection of devices. Physical means they're connecting devices. You can connect the devices in different ways. Depends upon the way of connecting the devices. Depends upon how you connecting the devices is called a physical topology. How you connect the devices, the way of devices connected is called a physical topology. Okay, so that's I'm searching who is joined. Very good. Search. Okay. So what are the physical topologies are there? First topology, ring topology, mesh topology, star topology, hybrid topology. These are the standard topologies from my textbooks, old textbooks. Of course, there is a lot of other topologies, almost all hybrid type on, like point to multi-point, tree topologies, hub and spoke, spine and leaf. So these are all different types of hybrid topologies. Okay. Yeah, usually guys, I will draw and I will explain. And so I don't want to do right now. That is, I'm going to take a existing one and explain. This is good. Okay. So, which is I draw the drawing only, but I like to draw and explain. So, but thing is, already I told you networking is very big topic. So, we'll see that. So, guys, I have taken a system, devices, and these devices are directly connected to a backbone cable. So, this is our backbone cable. Okay, this is our backbone cable. Most of the case, this backbone cable is a coaxial cable. Generally, we use a coaxial cable. Okay, and devices are connected to this coaxial cable, and devices are communicating through this cable only, backbone cable only. Devices are communicating each other. So data is mainly transmitting through the backbone cable only. Okay, next. Of course, this type of topology we call it as bus topology. It's very simple to configure, difficult to troubleshoot. Single coaxial cable support up to 800 meters. Okay, after 800 meters, you can attach one more, what we can say, a repeater. So then much longer distance also you can able to communicate with help of these repeaters. So more number of devices you can connect to this backbone cable. Okay, so means like a scalable. Okay, next. This is not a new one, guys. It is very old one, as well as in we are also know it. Maybe you don't seen, but I have seen that one. Okay, okay. So cable TV network is there. Cable TV. So there is a in a towns or big towns, even cities. Earlier it is. Now it is dedicated to small towns only, not in the villages now. The villages people are getting dish antennas. So what they have to, there is one cable TV office. They have dish antenna. They receive all the satellite signal. They put it in a mixer. They run a coaxial cable to the entire streets, home to home. So anyone I want a cable TV network, they attach to this cable like this. This is a T cable is there. So means there is a kind of T joint like this. Okay, a cable runs here and split here. Again, it will run. There is a T joint. Again, there is a splitter. It will go to one TV. This is all go to another TV. So later, with a certain uh, kind of regulations, they put a setup box here to regulate and channel divisions and regulate how many subscriptions there are having like that. Earlier number of subscriptions not counted. Okay, by government. Now government want to know everything about this subscription plans. And now this also removed and directly dish antenna. So from dish antenna, there's also coaxial cable to your setup box, from there to your TV. Okay. So we use this for the TV based communication. And in certain countries like US based countries, they use this for both network, internet, and cable TV purposes. So entire data is transmitting through this coaxial cable. The data transmission also is like a simplex or a off duplex mode communication only. Single channel communication. So simplex or a off duplex communication means at a time communication is also difficult. Next. In case one of the device is down, only this particular device won't communicate to anyone. The remaining devices will communicate each other. If this cable is down, means C2, the central device, that cable is broken. Only C device cannot communicate to the rest of the devices. Remaining devices will communicate. But if central cable someplace it is broken, further communication will stop. Okay, it means some devices unable to communicate each other, some devices will communicate each other. Okay. So this is what it is, bus topology. So it's difficult to troubleshoot also. Okay, easy to configure but difficult to troubleshoot. Why? Because where the wire is broken, we don't know. Okay, where the wire is broken, we don't know. So we have to get that kind of complaint. So I'm unable to communicate to particular device. Is that device related issue or a backbone cable related issue, protocol issue? We don't know. And exactly what devices are unable to communicate, where it is stuck. You have to check entire cable and find out where is an issue. Then you can able to restore it. So meaning is, guys, any troubleshooting, any issue occur. First of all, we should know there is a issue is occurred. Definitely, we should know there is a issue is occurred and where is it is occurred. Okay, first of all, we should know there is a issue is occurred and where it is occurred. And based on that, we can able to troubleshoot it. Okay. Here it is little difficult to get both the things. Next kind of topology. So here it is, a device is connected to another device. Other device is connected to another device like this. One device is connected to another device and the last device is connected to the first device. Like this, it is created a loop. It's created a kind of loop circuit. Okay, a closed circuit type. A is connected to B is connected to C is connected to D is connected to F, and F is connected to A. Okay. If A want to communicate it to D, A send packet to B and B to C, C to D. Now D reaches the packet. Now D want to reply, D send packet to F, F to A. Means the communication is always either clockwise direction or anti-clockwise direction. Every device you have to specify that any packets come, I have to send through this side only, this side. And this way, a packet is entered, it will send to this device. Okay, like that. It will check this packet is belongs to me. No means send it. So it works based on that kind of algorithms only. Of course, it is two-way communication is there, but not directly. Okay. Yeah, it's easy to configure, difficult to troubleshoot, difficult to scale also. What is meant by scaling? You added one more device. Again, I have to change the connectivity and I have to reconfigure how to reach the destination. So that's it, sir. Adding one more device is a little bit challenging. More number of devices increases, the delay in the delivering of packet is also take time. Next step. One of the devices is down. What happened? A to B communication is stopped. Okay, D can able to communicate A, but A cannot communicate it to D. Okay, so one device is down, one way of communication will be stopped. If B to C connection is down, means A reaches up to B, but now cannot reaches to C. C can able to reach A. So one way communication will be down. It's like a half duplex based communication will happen. Okay, this type of topology we call it as ring topology. Ring topology. Hmm. Next up, mesh. Some people think this is the star topology. Why? Because when people are writing this, drawing this mesh topology, first they draw a star and put the devices. So in our topologies, there is a star topology also there. So they started confusing, and even some people will confuse you also. So, but it is not a star topology; it is a mesh topology. So star topology is not a Christmas star; it is a mesh topology. And that too, you have taken a devices, that too 5 devices. So definitely it is look like that one only. Okay. If you take 7, 8 devices, it won't look like that one. You take more devices, for example. Take more devices like this. See, it's not look like that one. Okay. So this is a mesh topology. Then what is a mesh topology? It is a device is connected to all other devices. A device is connected to all other devices. A is connected to B, C, D, E also. E is connected to A, B, C, D also. It is complex to configure, complex to troubleshoot, difficult to scale, but it is redundant. But it is redundant. Next. Here it is. If one of the devices is down, only this particular device unable to communicate, rest of the devices will communicate each other. For example, this wire is broken. Only this device cannot communicate, but it will communicate it to other devices. Only this path is broken, remaining devices will communicate each other. So that's it is redundant. Okay, redundancy. One way or other way, there is a communication part is there. Of course, it's difficult to troubleshoot. Devices are communicating, and we should know some devices are unable to communicate each other. Only we know there is an issue, so we should say difficult to troubleshoot. Difficult to scale means if you add one more device, again you have to put all the connectivities. It is difficult to scale. Complex. Yes, it is so many number of connections. You have to be compulsory map all these devices, which device connected to which device, and which way it is connected, which point it is connected. We should know it. More number of devices increases, very difficult to connect it. Okay. So this is a mesh topology. One device is connected to all other devices. Every device is connected to all other devices. Okay. Okay. So bus topology, ring topology, mesh topology. Then we will go to the star topology. In this star topology, we are using a device, either hub device or switch device we are using. We are connecting all our devices to this hub or a switch device only. It meaning is all these devices are communicating each other through this hub or a switch device only. So A is communicating to B through this hub or a switch only. So devices will communicating each other through this switch only. Switch or hub device only. Okay. So this is called a start device. If there is a centralized device, all other devices are connected to centralized device, they will communicate each other. So this is very simple to configure, simple to troubleshoot, easy to scale, easy to configure, easy to troubleshoot, and it is scalable. It is scalable, but not redundant. Okay, okay. Once again, we'll see. For example, this C device is down, so only C device cannot able to communicate to the rest of the device. The rest of the devices will communicate each other, but C cannot communicate. Yes, C is down. Or maybe this cable is broken. Oh, shit. Okay, okay, okay. So just some network issue. Okay. F is disconnected from this switch. We have to switch or hub. The cable is broken, not working. So F is also cannot able to communicate, but rest of the devices will communicate each other. So same as this other things, right? But still, there is one more problem. If centralized device is down, total communication is stopped. If centralized device is down, meaning is centralized total communication is stopped. But as I said, it is simple to troubleshoot. How? For example, this hub and switches having a LED LED status at these ports or separately. Okay, sometimes some hubs and switches where you are connecting these ports, there is a LED blinking. For example, C is unable to communicate. So you can able to see where C is connected, is LED is blinking. No means either cable problem, C is problem. You can understand from it. Total is down means hub or switch is completely failed. You can see this LED blinking, power LED blinking. Yes, entire switch is down. So replace the switch immediately. Okay. So we can understand where is an issue when issue is occurred. Then you can how to troubleshoot it also. So this is called a star topology, guys. In our our regular LAN communication, our network communication, we are using this star topology only. We're all using star topology only. We are not using bus, ring, or mesh topology. We are using star topology. Of course, the mesh is also used, but different ways, different places, not for our regular network. Where it is using, also tell you. In a star, already I told it's a scalable. Scalable means you can extend your topology size also. Means, for example, you take a hub. Hub is generally available. 8-port hubs are there. 16-port hubs also there. Switches available like a 8-port, 16-port, 24-port, 48-port, like this. So different sizes of switch port switches also there. So for example, you take 24-port switch. So almost 24 devices you can able to connect it. For example, you have a means you have a 40 devices are there. How to connect 40 devices? You have a 24 port switch on. Only in your company, we are using only 24 port switches. All switches are 24 ports only. But we have 40 devices to connect it. How to do it? Simple. So connect some devices here. We have 40 devices, so I connect 20 devices here. 20 devices to another switch. 20 devices to one switch. 20 devices to another switch. And we are connecting this switch to this switch using TP cable. It's possible use a crossover cable. Okay. We are connecting a switch to another switch. Now all 40 devices are connected in the same segmented network. Earlier, this is one segmented network. This is another segmented network. Now you are combined two switches together. Now it is single segmented network, and these devices will communicate it to these other devices also. Okay. So this is called a extended star topology. Star means you have a hub or a switch, you connected devices to it. Then what is extended star topology? We are connecting another switches to our switches and connecting devices to those switches. So this is called a extended star topology. Sorry. Okay. Up to star topology. What are other things? Point to point. Point to point. You have a head office and there is a branch. New York head office, Hyderabad branch office. Their architecture, their organization, their devices that are connecting to our branch office, like one point to another point. Your branch office, your head office having multiple branch office, means one point to multiple point connection using WAN connectivity. And my point to multi-point, another example is satellites. Satellite transponders. Only satellite, right, is connected to the multiple transponders. Means other sites also, like point to multi-point. Another example. Tree topology. What is this? Tree topology. Different topologies are connected to a backbone cable, simply like you are following a bus and other topologies. So connected to that backbone cable only, and they will communicating each other. This is also a kind of hybrid topology only. Fine and leaf. This is fine and leaf architecture. This is a kind of hybrid topology, which is combination of star and mesh topology. Earlier days, we call them as full mesh topology. Now we are calling it as spine and leaf topology. There is a spine, there is a leaf. Okay. Spine layer, leaf layer. So where we use, this is a combination of mesh, means one device is connected to the all other devices. See, this switch is a multi-layer switch, is connected to other switches, leaf switches. This is spine. These are the leaf. Okay. Like this is the like trunk, and these are the branches. So why this is important? Guys, we use this for SAN area, so storage area network. In this SAN or storage area networks, we use this one for redundancy. Okay, redundancy. In case one of the switches down, bottom switch is down, sorry, so there is a another path to communicate kind of stuff. So where we use in a SAN storages and okay. So one line is down, or maybe one switch is down. So we can have another way to communicate. So that is why it is used panelly. Okay, means in a storages one switch is down. So other through other switches we are able to communicate. So that's it is created spine and leaf. Hub and spoke. Hub and spoke is nothing but hub and spoke is generally is a kind of topology. It is like a star topology only. But in this hub and spoke also there are different designs also. Okay. So hub and spoke is like a star topology actually. Also there is lot of hubs and spokes. Okay, these are the your topologies. And after that one we are using mainly star topology. Hmm. Guys understand?